Beta, let's start with some important examples in which you have to find out that which reaction will give E1 and SN1. Okay, the condition for E1 and SN1 is quite same. Every time the condition will be same. Each and every condition will be same. For example, means attacking of nucleophile. Okay, what happened? Again, same conditions. Tertiary carbocation required, है ना? अगर नहीं है तो rearrangement होगा. So many things which are related to them are similar, but the major difference is temperature. This temperature, this important property will decide that which reaction, this reaction will give SN1 or E. Okay, so let's just understand this thing with the help of example. तो हम कहाँ से शुरू करते हैं? We'll start with alkyl halide. Clear? Alkyl halide E1 reactions. Okay, let me just give you one alkyl halide. For example, CH3, CH2, CH3, Br. First we'll see, is this compound is stable? Yes. Or valencies are satisfied. Okay. Now, the basic condition to perform this reaction is weak base. Note it down. These are the most important things which are required. Weak, which are required for a even. Okay, even type of reaction. So here is weak base, and that can be CH3OH. This is your base. Second condition is temperature. 60 degree. 60 degree is quite high temperature. You know? So what happens? So this will goes directly from this. कैसा क्या हुआ? यहाँ पे the means the carbon with which your halogen group is attached, that is considered to be as alpha carbon, and adjacent carbon are beta. So this one is also beta and this one is also beta. So ये क्या बोलते हैं, this bromine will get out from this carbon, but hydrogen can be eliminated from this carbon and this also. Clear? तो हम इधर से भी निकाल सकते हैं हाइड्रोजन, इधर भी. So that is why these two are beta. So your product will be CH3 CH double bond CH3. ये सिंपल है. बच्चे यही करेंगे कि भाई ब्रोमीन यहाँ से निकालेंगे, एक हाइड्रोजन यहाँ से निकालेंगे, they just form a double bond. But this will not be applicable in every condition. ये हर कंडीशन में applicable नहीं होगा. ठीक है? Options में in multiple choice you will get this option also and the other one also. So this will not be applicable at each and every condition. For that you must know the mechanism. मैकेनिज्म के बाद जो हमारा फाइनल प्रोडक्ट आएगा वो कभी कभी बिल्कुल डिफरेंट आता है, एंड दैट विल बी क्वाइट डिफरेंट फ्रॉम आवर एक्सपेक्टेशंस. हम सोच भी नहीं सकते कि ये प्रोडक्ट बने. व्हाई? बिकॉज ऑफ रीअरेंजमेंट. आई हैव ऑलरेडी टोल्ड यू द थर्ड डिग्री कार्बोकैटायन, है ना, दिस थर्ड डिग्री कार्बोकैटायन और स्टेबिलिटी is the basic need, है ना. Stability of carbocation is the basic need. For stability, sometimes rearrangement takes place, which results in the change in final product. Clear? Let's just start with the mechanism. This is very important, beta. You must be familiar with the mechanism because this can affect your answer. Okay. So let's just start with the first step. In first step, what happened? The bromine will get out of this compound. So CH3, CH2, CH3, this is our main compound. So in first step, elimination will take place. Elimination of bromine will take place. So minus Br negative. Okay, 60 degree is the condition, basic condition. So what will be our product? CH3, CH2, here CH3. So what happened? The valency get unstable. wait a minute, 1 2 3 4, you didn't notice about this CH2, this is CH not CH2, इसी ने भी notice नहीं किया है ना. Valency of carbon is unsatisfied here. Okay, so what we will write here, CH and carbocation will come. What type of carbocation is this? 1 degree. कौन सा कार्बोकेटायन बना बेटा? 1 degree. क्लियर? यहाँ पे कहीं 3 डिग्री या सेकंड डिग्री बनने का चांस है नहीं है, तो वी विल गो विद दिस ओनली, हम यहीं से आगे चलेंगे. ठीक है, so what happened again when this reactions move to the second step, then what will happen? Hydrogen from this will eliminate, है ना, in the presence of CH3OH. So you will get CH3, CH, CH2 now. Okay, so what happened at this time? This electron and this electron forms a double bond, and your final product will be like this. Okay, so this will be like this. Clear? पहले step में bromine बाहर गया. Condition is 60 degree temperature. So this is what? This is halogen elimination. After that, elimination of hydrogen will take place. One hydrogen from this carbon will remove out. So for example, this, we will write this hydrogen here, and this carbon and this carbon form a double bond. What happened in SN1 condition? If the temperature is low, अब हम second step पे जा रहे हैं. I'm just changing the color of pen so that you can understand. For example, this compound at 10 degrees Celsius in the presence of same CH3OH, we have OH here, but condition changes, 10 degree temperature. So what happens? At 10 degree temperature or at low temperature, this will behave as a nucleophile. Clear? And what is the property of nucleophile? Nucleophile itself get attached with the compound. So your final product will be CH3 at alpha hydrogen, alpha carbon. Your OCH3 will combine, and this will be your final product. So this is SN1. This is E1. Clear? See the difference. At high temperature पे क्या होगा बेटा? उसको मौका ही नहीं मिलेगा वहां पे combine होने का. So at that time elimination reaction will take place. सीधा पहले bromine गया, फिर hydrogen beta से गया, है ना? From beta carbon, the hydrogen will remove out, and you will get your product. And in case of low temperature, even though we have same weak base, what happened at that time? This base will behave as a nucleophile and get attached with the compound and form SN1. So this is SN1 and this is E1. Note it down. This is very confusing. Okay, so the main condition which you keep in your mind is temperature. This is the game changer. Clear? Okay, let's just understand this thing with another example. Okay, let me just give you a question. I'm just writing it here. CH3, CH2, CH, Br, CH3. Basic condition is CH3OH, and let's just change it to 80 degree. I'm just increasing the temperature from 60. I just took it as 80. Okay, so what happens? In first step, it means your halogen elimination will take place. This boron will remove out of, which get out of this react compound. Br negative minus Br negative will be there. So CH3, CH2, CH, CH3. Up now, this one is alpha, this one is beta, this one is beta, this one is beta. Means each and other means means this other than this alpha carbon, each and surrounded carbon will behave as beta. This is gamma. This is beta, this is beta. These are the adjacent carbon. One next and one is preceding. So what is, they are considered to be as beta. उस अल्फा कार्बन को सराउंड करने वाले या टच करने वाले नियरेस्ट जो कार्बन होंगे उनको हम बीटा कार्बन बोलेंगे. ठीक है, अब सी व्हाट हैपेंड. कार्बोकेटाइन फॉर्म हेयर, ठीक है। नाउ कैन दे डू रीअरेंजमेंट, यहाँ पे कोई रीअरेंजमेंट पॉसिबल है? नहीं, बिकॉज ईच एंड एवरी कार्बन इज 1 डिग्री कार्बन, so no rearrangement will be there. I'm just mentioning here, no rearrangement will be there. Clear? But if there is a chance of getting means carbon other than primary, either secondary or tertiary, then rearrangement will be there. I will explain you those type of examples also. So what happens? You will get two types of product here. What type of product? Either your hydrogen will remove out of this carbon or this carbon. So let's just take it as two products. So for example, these are the two products. I'm writing both of them. CH3, CH2, CH double bond, CH2. This is the first product. Again, CH3, CH double bond, CH, CH3. दो कंडीशन है ना हमारे पास। तो भाई आप तो ये बोलोगे भाई मैम हमने ये टिक किया, हमने ये टिक किया, दोनों सही है। Why? Because ये क्या कहलाए जाएंगे? ऐसी कंडीशन में you will get cis and trans isomers. These are the exception type of questions. आप लोगों ने पढ़े होंगे। cis and trans याद है ना? cis trans mirror images जो होते हैं, ठीक है। अब आपको कैसे पता चलेगा मैम कि भाई which one is more stable, which one is the major product, as you can say, ठीक है। कैसे आप लोग बताएंगे उसमें कि मैम which one is the more stable? So for to know that you must know SEC rule. What was that? Note it down beta, this is very important. SEC rule ने क्या बोला था कि when your small alkali attack on more stable, means when your small alkali attack you will get more stable alkali. हमारा सेम है कि भाई अगर एक स्मॉल बेस से हम रिएक्ट कराते हैं, अगर हम ये कहें, इसको हम ऐसे लिख ही लेते हैं, when a small base attack, or small नहीं, in case of in place of small you can write weak. When weak base attacks, so what happened? Then more stable alkene will be the major प्रोडक्ट। याद रखना बेटा, ये माइनर मेजर फाइंड आउट करने के लिए बहुत आएंगे, तो ये SEC रूल बिल्कुल कीप दिस थिंग इन योर माइंड। क्या होगा? whenever we are taking a weak base, है ना, there we are taking a weak base, so what happen? we will get a stable alkene. हमारा मेन पर्पस क्या है? यहाँ पे हम एल्कीन्स बना रहे हैं फ्रॉम एल्केल्स, एल्काइल हैलाइड, फ्रॉम एल्काइल हैलाइड वी आर मेकिंग एल्कीन्स। तो जितना वीक बेस होगा उतना ही स्टेबल एल्कीन हमारा बनेगा। अब सिस और ट्रांस में से स्टेबल कौन सी है? अगेन उन्होंने फिर एक चीज बताई, मोर क्राउडेड इज स्टेबल, मोर क्राउडेड एल्कीन इज स्टेबल। हमें वहां ध्यान देना है दैट विच वन इज मोर क्राउडेड, ठीक है। या फिर हम बोल सकते हैं मोर सब्स्टिट्यूटेड, स्टेरिक हिंड्रेंस, मोर स्टेरिक हिंड्रेंस, so many words are here, ठीक है बच्चे। so the carbon means in which we have more crowded alkene, that is stable, that will be your major product, and less crowded will be the minor product. Clear? So let's just make a open chain like diagram so that you can understand that which one is trans and which one is cis. So for example, I'm just elaborating these two compounds, na, doing this arrangement around the alkene. Now we have double bond here, hydrogen, CH3, hydrogen, plus CC, CH3, H, H and CH3. So this is cis, this is trans type, है ना? इसी तरीके से मिलते हैं. This is this and trans is this. So at that time, as you can see, that both the carbon are, means which one is more crowded? Clearly, आप इसमें से बताएंगे कौन सी stable है, कौन सा ज्यादा crowded है? दोनों. So मैंने पहले ही बोला था, this is the exception type of case. In cis and trans, you can't just means find out the crowded one. See, यहाँ पे हम कैसे find out करेंगे कौन सा होगा इन दोनों में से stable? एनसीईआरटी ये कहती है बोथ होंगे, लेकिन बाद में इसको डिनाई कर दिया यूट्रैक ने. उसने क्या बोला कि अगर आप सिस और ट्रांस की स्टेबिलिटी की बात करते हो तो वी हैव टू फाइंड आउट द मींस इन विच अल्फा कार्बन इज मोर क्राउडेड. सो दिस वन इज द अल्फा कार्बन फ्रॉम ब्रोमीन डी अटैच्ड, दिस वन ना. यस. So which one is more crowded? This one. This will be the major product. How? See, there is a carbon. Count the alpha hydrogen around the central atom. हम कैसे पता लगाएंगे? हम अल्फा हाइड्रोजन काउंट करेंगे बेटा. अल्फा हाइड्रोजन क्या होते हैं? तो हमारा अल्फा कार्बन है उसको सराउंड करने वाली सारी हाइड्रोजन काउंट कर लो. दीज आर अल्फा हाइड्रोजन. कैसे? 3 4, यहाँ पे कितनी हुई हमारे पास, और एक इसकी 5, यहाँ पे क्या हुई 2 2 4 और एक 5. तो टोटल वी हैव 5. तो यहाँ पे हमारे पास दोनों ही मेजर प्रोडक्ट बनेंगे. कैसे? कि भाई हमने दोनों रूल लगा लिए अकॉर्डिंग टू एनसीईआरटी वी टुक and according to on the basis of alpha hydrogens we took. So both will be your product. Either you write this, either you write this, both are correct in this case. So these are the type of exception type of case in which you have two phases, cis and trans phases. ठीक है? Now let's just move to one more example so that you just understand this thing more clearly. For example, let me just change the position now. CH BR 1 2 3. I just want to make it 2 degree. Then 3 will be rearranged. So this will be CH3 CH2 CH2BR. Okay, let's just make a change so that we can make a stable carbocation. So this will be CH3 CH CH2BR. With this carbon I have attached one methyl group. Okay, in presence of H2O at 60 degrees Celsius. So what will be the final product? So generally what student used to do, they just substitute this bromine here and they will form a bond. लेकिन यहाँ पे ये बनेगा नहीं. See, let's just try to make it CH according to you this will be the answer, but this is wrong here. Why this is wrong? Let me just explain you. अभी just हमने क्या पढ़ा था? Mechanism. We have studied about mechanism. That mechanism is just play a different role, is just change the product also. So let's just go through the mechanism. Okay. First, substitution of bromine will be there, means elimination of bromine will be there, minus Br negative. So what will be the product? CH3 CH CH3 CH2. Okay. So what type of carbocation you get here? For example, this is your carbocation because bromine eliminate from this carbon. Na? This is your carbocation. So since this is 1 degree carbon, this is 3 degree carbon. So possibility of rearrangement is there for stability. So what happens? Rearrangement. And this rearrangement will change your answer. So what type of rearrangement is this? Since this was the alpha carbon, these are the beta carbon. Okay, this is the first carbon, this is the second carbon. So 1 2 hydride shift, 1 2 hydride shift will be there. अब ये 1,2 हाइड्राइड शिफ्ट क्या है बेटा, बहुत ध्यान से देखना, बहुत कंफ्यूजिंग है ये, वरना बाद में कंफ्यूज हो जाओगे. व्हाट हैपेंस, to form a tertiary carbon, this carbon will donate hydrogen to this CH2, है ना? This is donating its hydrogen to this CH2. So what happened? In next step, we will get a carbocation here. कैसा carbocation बनेगा हमारे पास? CH3, C, CH3, C. Hydrogen from this carbon shifted to this one. So this will become CH3 and this become C, CH3. And this will be your carbocation. Now we have which type of carbocation here? Third degree. As we know, third degree is more stable than 2 degree than 1 degree. Clear? We know this thing very well now. So now we have stable carbocation here, and this is the basic need. Formation of stable carbocation in both, in E1 and in SN1 also. In A1 and SN1, stable CC will be, formation of stable CC is the best means condition here. Okay, basic need, as you can see. Now let's just move to the another step. What happens since we have a stable carbocation? So this will be your alpha carbon, this is beta, this is beta, and this is beta. All are beta since all carbons are surrounded, all carbon surrounds the central carbon atom. So all are considered to be as the what? Simple. CH3, CH. So let me just, for example, I'm just removing hydrogen from here. So carbon, CH3, CH3. And now we have double bond here. Okay. This will be your final product. अब बच्चे पूछेंगे कि मैम यहाँ पे भी हमारा ये आंसर आ रहा था और यहाँ पर भी ये आंसर आया है, तो आपने इसको गलत क्यों बताया? आपने पहले बोला कि नहीं मैम ये गलत है. ये मैंने इसलिए बताया बिकॉज आप लोग क्या करोगे, एवरी टाइम आप यही सोच के चलोगे कि आपने एलिमिनेट करना है, डबल बॉन्ड बना देना. ये इसी के केस में या फिर एक दो और केसेस है, उनमें ही फाइनल प्रोडक्ट हमारा सेम आया है कि भाई हमने एलिमिनेट किया एंड वी जस्ट पुट इट. व्हाई? बिकॉज यहाँ पे कार्बोकेटाइन ऑलरेडी टर्शरी बन गया था पहले ही, यहाँ से ये हटा, डबल बॉन्ड बना, नाउ वी हैव टर्शरी मींस कार्बोकेटाइन हियर, है ना, सिंपली ये टर्शरी बना. so there was a condition, but if in case I add one more CH2 here, अगर इस चेन में एक और CH2 मैं यहाँ पे ऐड कर दूं बीच में, तब क्या होगा? The probability of getting third degree carbon becomes 0. तो उस टाइम पे ये गलत होता है. इसीलिए मैंने आपके ध्यान में पहले से ही डाला कि भाई अगर आप ये करोगे तो ये गलत ही होगा. एवरी टाइम दिस विल नॉट बी सक्सेसफुल. हाँ, लेकिन हम मैकेनिज्म के थ्रू जाते हैं एंड यू विल गेट द सेम आंसर. दिस मींस यू वर करेक्ट. क्लियर? पहले से ही माइंडसेट नहीं करना. अब क्या होगा? इफ इन केस SN1 बनाते हैं अब इससे, if in case I just reduce the temperature, ठीक है, and perform this reaction in presence of H2O, so what will be the product? At this point of time, it will behave as nucleophile. Clear? I've clearly mentioned you at low temperature, your reagent will behave as nucleophile. So what will be your product? This will be CH3, CH, CH3, CH2OH. This is SN1. Clear? That was your E1. क्लियर है? आप डायरेक्ट यहाँ पे एलिमिनेट कर दोगे. ठीक है, तो यहाँ पे क्या होगा? यू विल गेट SN1 टाइप ऑफ रिएक्शन. लेट्स जस्ट टेक वन मोर टाइप ऑफ क्वेश्चन. फॉर एग्जांपल, let's just move to the cyclic compound now. है ना, सिंपल तो we can do, alkyl halide, simple alkyl halide we can do, but there is a problem with the cyclic compound. So for example, if I have this one, chlorine is attached with the cyclic compound, CH3OH, 60 degree Celsius temperature, simple even बनाना है. ठीक है, so what happens? What will be the product? If I ask you, then what will be the product? So first let's just go through the mechanism. हम सीधे mechanism से चलते हैं. First elimination will be there. So Cl negative will be there, है ना? Elimination of Cl negative. After that, what you will get? You will get this type of carbocation. Is this stable? Beta, is this stable? No, na. Because since we have 3 degree carbon here and this is 1 degree only. So what happened? Again, rearrangement will take place for stability. कहाँ से कहाँ जा रहा है? This is first carbon, this is second carbon. Clear? Your hydrogen will move to this carbon and this one will become 1 to hydride shift. This minus H will move to this hydrogen, and what you will get after the rearrangement? This will be your carbocation. Now this is the 3rd degree carbocation. So this is considered to be as alpha carbon. This is beta, and this is beta. Now we have 3 beta carbons attached with this central. So this is tertiary, and since this is considered to be as more stable carbocation. Okay. After that you will get 2 types of product. One is major, another one is minor. कैसे? अगर यहाँ से elimination होता है, अगर I am eliminating hydrogen from this carbon, तो double bond will come over here. कैसे आएगा? ये देखो. This will be your product. Clear? If I am eliminating hydrogen from this. Plus second product will be, if I will eliminate hydrogen from this carbon, तो double bond यहाँ आएगा. Or if I will eliminate hydrogen from this carbon, तो double bond यहाँ आएगा. दोनों में से कोई भी हो, product will be same. So for example, I am just eliminating from this one. तो ये बना. So now we have 2 products. So the first condition is you have to find out that which one is major and which one is minor. कैसे? On the basis of alpha hydrogen. Count the alpha hydrogens. Since this is the central carbon, we have CH2 here and CH2 here. Total alpha hydrogen 2 plus 2. 4 alpha hydrogens. Now let's just move to this one. Okay, this one. So what will be like this? If you just consider means hydrogens around this. So what happened? How many alpha hydrogens are there? Count and tell me. How many alpha hydrogens are there? बोलो बेटा. We have to find out more crowded. जितना ज्यादा crowded उतना stable. तो दोनों में से कौन सा ज्यादा crowded है? ये वाला. कैसे? This is CH3, this is CH3, and 1, 2, 3. This is CH.
इसका एक ये भी है ना, इसमें हाइपर कॉन्जुगेशन ज्यादा होगी.
Yes, more crowded मतलब more hyper conjugation. ठीक है? Steric hindrance, more crowded, more वो ज्यादा होगा. So which one is the major? This one will be the major, and this one will be the minor. Clear?
अगर कार्बोकेटाइन और हाइपर कॉन्जुगेशन में दोनों में से देखना हो कौन सा ज्यादा सही है, तो पहले क्या
अगर stable, if you सुनो note this thing down. If you have 3rd degree carbocation ना, 3rd degree अगर कार्बोकेटाइन हमारे पास है, तो जो कंजुगेशन होगी आपकी हाइपर कंजुगेशन विल बी मोर. और अगर 2 डिग्री होगा तो उससे कम हो जाएगी, 1 डिग्री होगा तो और लेस हो जाएगी. तो कार्बोकेटाइन तो डायरेक्टली हाइपर कंजुगेशन को रिलेट करता है बच्चे. इफ टर्शियरी कार्बोकेटाइन इज देयर, प्रॉपर्ली स्टेटेड है कि भाई वहां हाइपर कंजुगेशन ज्यादा होगी. सी CH3 देखो, दिस इज टर्शियरी, है ना. सेकेंडरी में क्या होगा? सेकेंडरी में और कम हो जाएंगे अल्फा हाइड्रोजन. तो या तो आप हाइपर कंजुगेशन डायरेक्ट देख के कर लो, या फिर आप अल्फा हाइड्रोजन को कैलकुलेट करो. I have told you all the methods कि कैसे आप पता लगा सकते हो कि which one will be your minor and which one will be your major product. Clear? If 3rd degree carbon is there ना, कहीं पे भी 3rd degree stability तुम्हें दिख रही है, तो clearly you will just identify that more hyperconjugation will be there. So hyperconjugation is directly related to the stability of carbocation. Clear? And which is 3rd degree is more than 2 degree and 1 degree. Okay. We'll continue with the same. In next class, I'll give you some more examples so that these type of problems will become more clear to you, because this will create more confusion. When they ask you to find out E1 and SN1, so this all the conditions are same with E1 and SN1, but there are so many slight differences or slight things which can create a difference in your answer. Okay,